Okay, I'm just going to have a look at the fifth question from Thursday's class, which is this. A point A 4, 2 and C, 16, 11 are vertices of the triangle ABC. D and E are points on the line segments CA and CB, respectively. The ratio of AD to DC is 2:1. Find the distance from A to D. Okay. Well, my approach here, we know that ratio is 2:1. So what I'm going to do is I'm going to find the distance from A to C and then divide it in that ratio. It says find the distance from A to D. To find the distance from A to C, I'm going to use the theorem of Pythagoras, which says the distance, if I think about that being a little right triangle, I've got a horizontal change here and a vertical change. The horizontal change from 4 to 16, that's 12. The vertical change from 2 to 11, that's 9. So some of you might see this is actually already a 3, 4, 5 triangle. So you might be able to say already that that has to be 15. But if you're not sure, it's just the square root of 9 squared plus 12 squared. And that's 15. Okay? You could use the distance formula as well in there. The distance formula is just uses the Pythagorean theorem as well. So we know the distance from A to C is 15. We have to divide it in the ratio 2:1. That's 3 parts in that ratio altogether. Each part will be 5, which means this first line segment, which is 2 parts, will be 10. And that second line segment up there will be 5. So the distance from A to D will be 10 units. This is slightly cut off here. We're asked to find the coordinates of the points B and E, given that the distance from A to B is 33 units, and it's a horizontal line segment, AB and DE. So AB is horizontal and DE is horizontal, so they're parallel. That's also 33. Well, if it's horizontally, if B is horizontally across from A, there's no change in the y coordinate because it's not going up or down. And that's 33. Well, that's all a change in the x coordinate, which means that has to be 37. So there's B found. The next thing is to find E. And there's a theorem on our course called Theorem 12, which says essentially that if this line is parallel to this, and this divides the triangle, this side, in the ratio of 1 to 2, well then this gets divided in the ratio 1:2 also. So C to E to B, that's going to be in the ratio 1:2 also. Get rid of these. So that's going to be in the ratio 1:2. Okay? So again, there's 3 parts in that ratio, and I'm just going to examine the vertical change and the horizontal change. The horizontal change from 16 to 37, that's 21. Okay, so the horizontal change, the change in x, is 21. I'm going to break that up in the ratio 1:2. 3 parts in that ratio. So breaking 21 in the ratio 1:2, well, that's going to be the ratio 7:14. So the change in x is 7 across here and then 14. So we can work out the x coordinate starting at 16. A horizontal change of 7 will take me to 23. The change in y from 11 down to 2, well, that's a change of -9. And if I break that into the ratio 1:2, that'll be -3 is to -6. Again, looking at the vertical change here, starting at 11, dropping 3, and then dropping 6. But I'm looking for this point, a drop of 3 down from 11. That's going to be 8. So B is 37,2, E is 23,8. The distance from A to D is 10. Okay. There's also a formula for dividing a line segment in a given ratio, which you can use there. Also, I prefer just to think about it a little bit rather than use a formula.